Okay, so let's do some trig models and applications. So we have this right triangle here that we need to label. So A, big A, is the angle, and then the lowercase a, which is right across from it, is the side. So your angle is across from the side that corresponds. Okay, so let's look at how we can label this. All right, A is 7.4 degrees. Let me turn my pen on here. Okay, 7.4 degrees. And then we have little a, which is the side, is 20.5. And we need to find big B, which is an angle. We need to find little b, which is a side, and little c, which is a side. Okay, so I am going to start with angle B. So we know that it's a right triangle, so everything adds up to 180. So in order to find angle B, we know that this is 90, and that is 7.5. So we've got to find what B is. So the easiest way to find B is to do 90 minus 7.4. And that comes out to 82.6. So 82.6 degrees. And we should also label it on the triangle. All right. So then we need to get our sides. So let's use our original of 7.4. So this would be opposite, this would be adjacent, and this would be hypotenuse. So if I want to find the hypotenuse, I would use sine. So sine of 7.4 equals 20.5 divided by c. So in order to solve this, we would get c all by itself. So the easiest way to do that is to exchange these guys. And so we have 20.5 divided by sine of 7.4. So we're dealing in degrees, so make sure you are in degree mode. And you'll put this in the calculator. And it comes out to be 159.17. And it's a length, so we are not going to put degrees on there. So this was C, 159.17. 159.17. All right, let's find side B. So if we're using our 7.4, we have opposite and adjacent we're dealing with, so that's tangent. So tan is 7.4 equals 20.5 over B. We can do the same thing where we get B equals 20.5 over tan 7.4. Put that into the calculator and you get 157.84. So it goes here. And then a way to check is just to make sure that the sides opposite your biggest angles are the biggest sides. So like 90 is your biggest angle, so across from that is your biggest side. Then you go down from there. 82.6 is our next biggest, so across from that 157.84 makes sense. Then we have a really small angle, 7.4 across that is a really small side. So they're all relative to one another. All right, let's look at the next one. We have another triangle that we should draw. All right, and then across is B, across is A, across is C. So it tells me that C is 18.9, and we know it's a side because it's a lowercase. And then B is 1.32. So we've got to find everything else. All right, so let's find one of the angles. So I know that this is a hypotenuse. And if I'm trying to find A, then I could say that this is adjacent. So the trig ratio that goes with that is cosine. So cosine of angle A equals adjacent 1.32 over 18.9. And we want to be able to find the angle. So the way we do that is using the inverse sign. So I'm going to do inverse on both sides. And so then it looks like this. So this is where that arc sine or inverse sine comes into action. Okay, we put this in, make sure it's in degree mode, and we're going to put this in inverse cosine 132 over 18.9, and then that equals 86 degrees. Make sure you're still in degree mode because we want to get our answer in degrees. Because it's 85.99, we're rounding. Okay, so then we are going to look, let's go ahead and put this in there. We want to do B now, so adjacent, or that would be opposite now over hypotenuse. So I could say B, I would do opposite over hypotenuse. So sine B equals 132 over 18.9. And then you do inverse sine, inverse sine. So B is found by doing inverse sine of 132 over 18.9. Okay, and that is 4.00, so it's 4. And then we would just make sure that that makes sense. So we have 90, 86, and 4. So those all add up to 180. So then we're good. We could have also done this a different way and said 90 minus 86 gives us 4 instead of using a trig ratio. There's more than one way to do it. All right, let's go to our sides now. So I'm going to use angle A and do opposite over hypotenuse. So sine of 86 equals A over 18.9. Okay, so we do 8 times 18.9 because we wouldn't switch those. That wouldn't do any good. So instead we are going to multiply. So then the way to get small a is 18.9. Oh, put my decimal in the wrong spot. 18.9 times sine 86 equals. So 18.9 sine 86. 18.85. So that's what goes here. Or we can say 18.9 if we're rounding to 2 decimal places, or 1 decimal place. I would really want to show that because see how this has 9. If I round, then that's saying those are equal, and they're not. Okay, let's look at our last. Is that it? Yeah, we've got all of our items. We have A, we have big B, and then we have little a. All right, let's look at our last problem. It says find the altitude of the isosceles triangle shown in the figure. All right, so something we know is that if this is isosceles, see how these are equal? Then the opposite sides are equal as well. And then the altitude goes from that vertex straight down and makes a right angle. Okay, so we're asked to find the altitude. So this is our unknown, that's our x. So it tells me that this is the 62 degrees, 23 minutes, and 45 seconds. And it also tells me that the whole b is 3.1. But if I'm just looking at a right triangle, like just one side of it, I would take 3.1 and divide by 2 and get 1.55 on both sides. Okay, so now I have a right triangle, and this is my opposite, and this is my adjacent to that angle. So opposite and adjacent is tangent. So we're going to say tan of 62 degrees, 23 minutes, 45 seconds equals opposite x over adjacent 155. Okay, we want to solve this, so we're going to multiply both sides by 1.55. Okay, so we'll put that in the calculator. 1.55 times tan 62. You got to go to, in your calculator, the angle. And then 23, go back to angle minutes, and then 45 seconds. And then close your parentheses. Okay. And that comes out to be 2.96. And it would be centimeters. All right, that is it for our note.